video will help us identify the primary structures of the ear involved in auditory processing and analyze the transduction process as well. As we consider the transduction process, we have to think about what stimuli is actually entering the ear, and that's essentially sound waves. The actual characteristics of those sound waves will then translate into sensations and therefore perceptions. So the first option that we have is the amplitude, and the amplitude has to do with how high or how small the actual peaks of the sound waves are going to be. And these peaks, or the amplitudes, essentially come out as our loudness or our volume measures. Another type of quality that we're looking at with sound is the wavelength or the frequency. So depending how far spread out our different waves are going to be, whether they're very far apart or whether they're very close together, that frequency is going to directly translate to the pitch overall. And then we also have complexity. Complexity has to do with how many changes are going on in the wavelength. Is it increasing and decreasing the amplitude quite a bit, or the frequency? And that complexity level is going to translate as timbre. Now, from this process, though we are certainly starting with the sound wave, there's a fairly long process that the sound wave has to actually go through in order to impact the transduction process. We're going to go through this entire process step by step, but for now, do note that the transduction itself, and remember that the transduction is when we change from that external stimuli to the actual neural signal. In the ear, this doesn't happen until pretty far into the process. So if we contrast our auditory processing to our visual processing or our taste processing, for example, in those scenarios, transduction happens fairly early in the process. But in our auditory processing, the transduction isn't happening until we get to the very inner ear. And at that point then, we'll go through the auditory nerve, will impact the thalamus in the brain, and that'll allow us to move about the temporal lobe and make any other connections necessary. So let's go through this process step by step. So first of all, we have our sound wave. And that sound wave is going to enter at the pinna. The pinna is essentially the fleshy outer part of the ear. It's what we're really looking at when we take a look at the ear. Then it's going to travel through the ear canal. So this is a protected area in the head, and it allows this sound wave to really get this condensed version, so that way as the sound wave is moving in our ear canal, it's going to set up to essentially reverberate against our eardrum, which is the third part. So our eardrum is also known as the tympanic membrane, and outside of the tympanic membrane, we literally just have air waves moving. And when those air waves, which include the information for sound based on the amplitude, the complexity, the wavelengths that we have, that wave is going to hit the tympanic membrane, and it creates a vibration. Those vibrations then take us into the middle ear, which have 3 little bones. So in our original picture, you can see here in the lower left that we do have the eardrum still. So we're moving out of the canal, we're reverberating off the eardrum, and then the process is that all of these little bones, the hammer, the anvil, and the stirrup, are vibrating based off of whatever the sound wave was that actually hit the outside of the tympanic membrane. And that little bone, the hammer, the anvil, and the stirrup are going to beat, and literally the stirrup, the last one, beats directly on the next stage in the process. Now, before we move on to the inner ear, I do want to point out this word ossicles. Ossicles is the word for the hammer, the anvil, and the stirrup combined. So all 3 of those little bones make up the ossicles. The other piece that you'll see on here is we have the eustachian tube. And the eustachian tube is directly connected to our sensation of whether we're standing up, whether we're laying down. The eustachian tube essentially helps us determine our relationship to gravity. And this is important as we move into other parts of sensations. The eustachian tube essentially allows us to determine how we are interacting with our world. And for people who have issues with vertigo, for example, this is where those challenges lie. Now, once we move past the middle ear, then we're going to go into the inner ear. And the inner ear is called the cochlea. So when we take a look at the cochlea, it's this little snail-looking shape at the very end. And we have a close-up picture of the cochlea down the bottom, so that way we can go through all the pieces individually. Now, the cochlea itself has fluid in it. So the outer ear and the middle ear were really just air waves, and we were getting this vibration going. But as we move into the cochlea, we have this fluid-filled area that we still have waves that are happening, but they're no longer waves in the air. They're more like waves in the ocean. And so at the very beginning of our cochlea, we have the oval window. So keep in mind that we had these three different bones. We had the hammer, the anvil, and the stirrup. And the stirrup is literally pounding on this oval window, which then creates these waves in the inner ear. So this inner ear, in addition to the fluid, also has something called the basilar membrane. And this is a very thin strip of tissue running throughout the entire cochlea. And the basilar membrane is covered by cilia. This is how we're going to actually translate the waves that are happening now in this fluid-filled cochlea into an electrical signal. So the cilia is essentially moving, and as the cilia moves, we're able to translate that movement into an actual neural signal. Once we have that neural signal, that's where the transduction is happening. So ultimately, the transduction in auditory processing is actually happening directly on the cilia, and that's allowing us to move from that fluid-based wave to a neural impulse. And once it's a neural impulse, then we can go ahead and move it to the auditory nerve. So you'll see that the auditory nerve is sitting right on top of the cochlea. So we have all of the processing going on inside the cochlea, and then once it becomes a neural issue, then we're able to send it out through the auditory nerve.